Lens cataract can be modeled using AHEM. So the image we're looking at right now is a few rays being traced into the eye and being scattered around by a cataractous volume within the eye. So let's load up a settings file of how we might set this up. I'll start AHEM, and I'm going to use the saved settings file. Alright, so let's look at what we have here. I'm using scatter and reflections now, so I have this box checked. And I'm sticking with one wavelength for now. And I'm using an incoherent source. And for any kind of scattering, that's really what we need to use. I've got my AZI model, eye geometry. No correction, no ametropy or anything like that. I'm using a source target at 6 meters and filling the pupil with it. I have a small retinal window size of 0.05, or actually 0.1 by 0.1 millimeters. And everything else is pretty basic. I do a little averaging here. So I'm going to click OK. And now I get a splash screen that's relevant to splitting and scattering. So I have my split Monte Carlo option on, which can save ray trace time. And I have various options here for setting splitter and scatter levels for the various elements of the eye. So I can have a global scatter level. So if I have any other types of instruments or optics other than the eye, that generally applies to those optics. And then a sub-level of that, I can change the various scatter and split levels on the different eye elements. So I've got cornea split and scatter, aqueous split and scatter, lens split and scatter level. So here I'm concerned with scatter in the lens and not anything else really. So that's where I have my numbers set, is particular to the lens. If I have volumetric scatter, I want to have a high scatter level for that. Generally 100 is enough. I've got 1,000. Cataract mean free path is related to density. All right, so I've got 3.85 millimeters in this case, and then a particle radius. So these are some numbers that are found in the literature in modeling nuclear cataract. I have an option to plot a cataract function, so I might click that. And so I've got vitreous scatter and split. I can also have retinal reflectance as well. So if I send light into the eye, I can have it reflect out of the eye and do anything else with it that I want to afterwards. So I'm going to click OK, and then I get my particular geometry set up here. This is the AZ lens model once again. I'm going to leave everything set the way it is. And I click OK, and there's my lens volume scatter graphic. Alright, so I get a graphic here where I show some rays scattering, but I'm really interested more in the retinal PSF. So this is it here, and if we look at the numbers here as far as maximums go, what I've done is I've set various levels of scatter attenuation. So my particle size is staying the same, but I'm increasing the density of the particle size in the eye lens. So I've got 5 different levels of cataract set up, much like you would for nuclear cataract. And if I step through the different levels, this is the first level, and the second level, you'll see the numbers change up here as far as maximums, and over here, intensity of that point spread function. So as I increase the density, you'll see these numbers go down, and relative to the density of the cataract. And I keep going down, and there's a little more scatter out here in the periphery as well. It's gone down to 2.1, and even farther here, 9.2 e to the 4th instead of the 5th. And if I enhance this, I can see a little more of that scatter on the outside. So that's how light scatter behaves when you're keeping the particle size the same and increasing the concentration. I can also go in there and change the particle size as well as the concentration at once. So I can do either or both of those changes in scattering to model cataract.